my screen.
Yes, we can.
Okay. Okay, I'm starting from very scratch. Okay, starting from the fundamental concept. Okay, so maybe some people already know that I'm covering from the scratch. So it will not take much time, but it will be like I will be covering. Okay. Okay, so I have divided the complete syllabus into four parts. Okay, so data engineering. Okay, with cloud and DevOps. Okay, so here in the this syllabus, right? So the first is a on-prem. So on-prem is like Hadoop and Spark, Hadoop and Spark, right? So these all installation, everything we will be doing in the Ubuntu VirtualBox, Ubuntu in VirtualBox in Windows. Okay, and there we will install all the Hadoop Spark tools. Okay, so Hadoop tools like Hadoop is having um, SDFS, like Hadoop itself is having SDFS and MapReduce. Okay, SDFS is the storage component, and MapReduce is a processing component. Okay, MapReduce is a processing component. Apart from that, we have Hive, we have Scoop, HBase, Flume. Okay, so these are the tools are in the Hadoop component. Okay, and when we are installing the Spark, so Spark on the Ubuntu, we need a Python, Scala, because Python, Scala, both of the languages we will be using in the Spark. So Python will be using PySpark. So Python will be using the PySpark, and Scala will be Spark Scala. Okay. So we need a Python Scala is mandatory, right, for the Spark, right? So we will install the Spark also. Okay. So Spark 3.3 version we will install, and the Python and Scala also will install. So this all on premises. So we will be starting first on premises like Hadoop and Spark, right? So two main like categories, right? One is Hadoop tools, and the second one is Spark. Okay, and Spark, after first we will do the Spark transformation actions, and after that we will do the integration of the Spark with the different other tools, right? So it could have Hive, MySQL, and Cassandra, Mongo. These are the NoSQL database, Elasticsearch. Okay, and Snowflake is a NoSQL, it's a Cloud SQL data warehouse tool. So these are the different other, and the file system also, right? File system data, right? CSV, JSON, XML. So this is in Spark, we will be doing a ETL pipeline, and ETL pipeline is nothing but data ingestion, data transformations, and then writing data to the final destination target, right? That is ETL. So we will be doing in the Spark is ETL. So ETL could have extraction, right? So extraction layer, we can have different source of the data. So sources of the data, these are the all sources of the data. So these are the all sources of the data. We will be reading the data. And once we get the data, we'll get a data frame. And this data frame, we apply transformations. Okay. And various transformations will apply. So we will go through it. I just give the brief idea, like map is there, flat map, filter, join, group by key, reduce by key, okay, and union. These are the transformations, like conversion of the data one form to another form, that is transformation. So there are the different category of the transformations are there, wide transformation, narrow transformation. So you'll see in the Spark. And once we do transformation, finally loading data into target data store. This data store again, any of them could be, okay. It could be a Hive, it could be a MySQL, it could be Cassandra, Mongo, Elasticsearch, Hive file system. We can write the data. So it's a ETL pipeline. So in ETL pipeline, we have three layers: extraction, transformation, and loading the data into the target. Okay. So this is on-prem, and we will be doing all installations on the Ubuntu, so we don't need a cloud here. So third section comes, that is the DevOps. Okay, so DevOps is basically we will be creating an infrastructure, because when we are going for the cloud, so cloud and DevOps, these two are combination together, right? because DevOps is infrastructure, right? Like we will be using Git, we will be using Jenkins, we will be using Docker, we will be using Kubernetes, we will be using Helmchart in Kubernetes, Helmchart, and there are the other Terraform is there, right? Terraform also the infrastructure building tool. So Terraform also we can use, right, for infrastructure building tool. So these are the tools like in the DevOps we will be using for our data engineering. So we are not learning DevOps, right? We are learning DevOps for data engineering, right? So that is called DevOps. So this terms is called DevOps. Okay. So DevOps is a general term. Is a DevOps is the development operations, but DevOps is the data operations, right? When we are doing any DevOps relation operations, right? So we will be using in the DevOps. Okay. So this is the our third section, and fourth is cloud. Okay. So cloud, the one question comes like which clouds are right good to learn, right? So I will say the multi-cloud is in market, right? At least two cloud combination should be there. Okay. So first we see like how many total clouds are there, right? Which are good in the market: AWS, Azure, and GCP. So these are the top three leaders. Okay. But I say any two combination you can take it, but AWS is the most probably chances are like more, right? Like 60% we can keep it AWS, and other 40% you can keep it Azure GCP. Okay. So Azure GCP, you can keep it in the 40%. Okay. But if you want to go for the choice for the cloud, so AWS, Azure, you go, and GCP, you can just learn basic fundamentals like what are the GCP related AWS, GCP data engineering services. So in these clouds, what type of services we will learn? First is every cloud is divided into the different segment. Okay. One segment is infrastructure segments are there, like VMs are there, machines, right? So these VMs are basically machines, right? Those are the machines, and these machines have the OS, right? And these OS could be any of the OS, right? Mac is there, Windows, CentOS, okay, or Ubuntu, right? These are the different category of OS. So if I say in the GCP and Azure, they call it VMs, okay? And the same VMs in AWS, it is called EC2, Elastic Compute Cloud machines, right? And we need the any infrastructure we are going to develop, right? In the cloud, we need machines, right? We need data centers have the machines, and machines are there in the racks, right? So this is the terminology. So these EC2 machines we need, okay? Or we can say in the GCP Azure, we need the VMs, okay? So we need to learn how to create these machines, how to we can setting up these machines, right, for our infrastructure, right? Okay. So then second thing comes storage. Okay. So storage, I say the two types of storage. I say file system storage or database storage. Okay. So if I say file system, so these storage are across the cloud common, right? If I say the file system, so some file system is in the AWS, I say it is S3, right? We all know people, right? The S3 is there, and GCP is having GCS, Google Cloud Storage is there, and Azure is having blob storage. Okay. Blob container or container is there, right? So blob storage. So these are the storage area. Okay. These are the file system. All three are the file systems, right? Where we can think of, right, any Windows file system or Ubuntu Unix file system, right? Similar that we have the file system. Data storage, data. So here again, two categories: SQL and NoSQL. Okay. And other categories also, like you can say cache database, right? Cache, right? Memcache and Redis cache. So these are the all also other category. If I say SQL, so SQL having the different other SQL tools are there, right? Like Oracle, MySQL, SQL Server. So AWS is providing RDS. Okay. MySQL. So RDS is a service which is provided by AWS. Okay, it is provided by AWS for SQL databases. Okay, AWS. And if I say NoSQL, so there are the different NoSQL is there: Cassandra, Mongo, So they are having a separate managed service. Okay. So Cassandra having some key spaces there, document DB. This is the name is document DB. Cassandra is the name key space. Something is there. Okay. So some service they have provided. These are the managed services and paid services. So when I'm talking about the managed services means the the load balancing, scaling, all those infrastructure things will be managed by the AWS, and these are the paid services. Even RDS is also paid. Okay. So when I'm using a managed services, so these are the paid services. Okay. And GCS and this all storage services like file system is not paid. Okay. And if I say these are the storage services are there, some are the services, analytic services. So our main focus in the cloud is the analytic services, because whatever this VMs and this storage, these are the common cloud. Um, like we any person is going as a cloud engineer, right? So he will definitely learn all these. Okay, these are the common services. But analytic services are for big data, for data engineering or big data. So for data engineering, we use this analytic services. So analytic services, again, there is having different services are there, like AWS Glue is there. Okay, Lambda is like a serverless. These are the serverless. All these are serverless means there is no EC2 machine is not required. Like any server is not required. That's the reason it's called the serverless. Okay, and EMR is there, Elastic MapReduce. This is a Hadoop Spark cluster. So same Hadoop Spark cluster which I have developed in my Ubuntu VirtualBox, same I can do in EMR, but this is a paid. This is the managed service. So these are the managed service. So managed service, but Lambda is serverless, but it's see all these services having some specific uses, right? If your usage is going beyond that, then you will be paid, and that uses is very high. Like you can say the millions of requests you are doing Lambda, okay, 1,000, and so there is some limit is there, but that limit is like monthly limit or like that limit is there. So that is not much paid, right? Okay. But EMR is hourly paid. Okay. Because when you are creating a Hadoop Spark cluster in EMR, so it will be hourly paid. Okay. So for these services we can use, okay, but we have to just whenever we are using it, we will use it, and we can uh, stop the service, right? We can stop the our VM. Okay. So AWS Glue, Lambda, EMR, DynamoDB. Okay, DynamoDB is a NoSQL database of AWS. AWS has provided its NoSQL database. Okay, if I talk about in the GCP, so GCP is having Bigtable and BigQuery is there. Bigtable is NoSQL database. Okay, and BigQuery is a SQL database, SQL data warehouse tool, same like a Hive. Okay, is a SQL data warehouse tool. And in the AWS, SQL warehouse tool is a Redshift. So these all tools we have to do, we have to learn, and then we have integrations, right? Like suppose I want to write the data into Redshift from the Spark EMR job, like Spark job in EMR cluster. So we will read the file from the S3 and write the data to the Redshift. So these concepts will come like when you are going through the cloud, right? So first we initially learn the cloud like VMs and the storage, and then we will move to the analytics services. Okay. So this is our fourth section. There we will do AWS 60%, I told. Okay. AWS 60% and rest is 40%. Okay. Our main focus is the AWS, but Azure I will do some Azure services are there in the big data services, data engineering services. So one is a data factory in Azure. So data factory is ADF, right? It is called ADF, Azure Data Factory. So Azure Data Factory is a ETL pipeline tool. That is a drag and drop tool. So you can have a different activities are there in ADF. Copy activity is there, meta activity is there, and lookup activity is there. Like you want to find something in your file, right? So you can use a lookup activity. So there are different activity are there, the source and target activity. So you can create a pipeline in the ADF. And the next thing comes ADB, Azure Databricks. So Azure Databricks is not proprietary to the Azure Databricks is a proprietary, but Databricks is a common general, like Databricks is common. So Databricks is in the AWS Databricks, okay? And when we say Azure Databricks, so that same Databricks is in different cloud, okay? But Databricks infrastructure is same across the cloud, but it is part of that cloud. Suppose you are learning AWS, okay, and there is a AWS Databricks option is there, and Azure is also having Databricks option. So any one cloud you do the Databricks, so Databricks is common, right? And GCP also Databricks is there. So the Databricks concept itself is same. So Databricks having a lot of concepts are there. Lake house is there, architecture, Databricks. So there is a delta table, live table, delta table. Okay, concept is there, live table is there. Okay, so delta table, like we can use a CDC, right? Like change data capture. Like we have to do insert, update, delete in our tables, right? So we use CDC. Okay, live tables are there, delta tables are there, and there are the lake house concept is there. Okay, so those things are the theoretical and practical part of the Databricks. Okay, so Databricks we learn, so we can do practice in any cloud, or even directly Databricks also you can practice, okay, without any cloud. Okay, so Databricks also having its like you can create a community, you can create an account in the database community version, and then you can do practice. Okay, anyone has any questions so far?
No.
Okay, so
Sorry,
yeah.
I have a question.
Mm.
For the storage, you mentioned the file system and database stores. What are the main differences on those?
File
Because
system is
they all store data, right?
they store all data, but they are the different way, right? So you know, right, file system is it's like Windows or Linux file system, like that dump the data, right? You can copy the files, right? But database is the like a tabular form the data. We have the interface as a table, okay, database table interface for the end user, okay, but in the back end it is a file itself. If you have seen like Oracle MySQL interface as a table, okay, table as a front end, okay, but backend it is a file. Backend it is a database file, we call it backend, it is as database DBF file, right? For any database, if you say like Oracle MySQL, so
Yep.
this tabular database we see the tabular representation, but backend it's a database file. But we are not concerned about the data like file system, right? How it is stored, right? Yeah.
Okay, thank you.
So we will see that, right? The SQL databases, basically we have when learn Python and the SQL, right? So SQL we have to cover MySQL, right? So MySQL if we cover, then it will cover most of the things Oracle, but some of the things are little bit different in the Oracle, like row ID is there, right? That is the different concept there in the Oracle. So we will see that those are the SQL queries, because databases we have to do practice, right? Because we cannot master in the queries in one day. So we have to try different queries. And even the SQL we will run in the Hive. Hive, when we will be going through, there is a Hive SQL is there. Okay, that is called HQL, Hive query language, and that is completely following the SQL. Okay, and when we are learning Spark SQL, so Spark SQL also using the SQL queries. Okay, so but this SQL queries in the Spark, the processing engine is a Spark, right? So Spark is a faster, right, processing engine as compared to other like a processing component, right? If I say MapReduce and Hive, so it is using in-memory computation. So that is the reason it is faster than the other MapReduce. So I will tell about differences, right? Okay, so there we will learn spark.sql and write a SQL query like select count star from table. So same, if we have the SQL knowledge, so we can learn, we can quickly do the SQL, Spark SQL and Hive SQL. Okay, so they're the different places we will learn the SQL as well. Okay, now if we start the fundamentals of the big data, right? So first we go with the definition of the big data. So big data is, the data is a very, very large amount of data. But what is the definition of the big data? Like this, what amount of size of the data I say big data? Like some MBs of data, GBs of data, TBs of data, so petabyte of data, right? So the definition is says, right, we have some characteristics are there, right? I say velocity. Okay, I say volume and veracity and variety. Okay, so these are the four V's we can say. Variety. Okay, so velocity, I say if the data is generating very fast speed, right? I say that the speed of the generation of the data is fast, that is called big data. Volume, so when the velocity will be high, definitely the volume will be high, right? So if I say the flight, right, which is traveling for 30-minute flight, so it is generating the sensor data, and the 30-minute flight is generating 12 terabyte of sensor data. So that's really huge data in a less time. Okay, so volume is high. Okay, and veracity is the data is, so if we are generating lots of data, but data is having truthfulness, right? The data is meaningful, truthfulness or meaningful, right? Meaningful. So that property is called veracity. So veracity is basically when the data is having a like a truthfulness or meaningful, right, characteristic. So that data is the big data, right? And variety is the data is coming from the different sources. Okay, so here we can say the data could be structured data, okay, unstructured data, or semi-structured data. Okay, so if I say structured data, so structured data is the data is a two-dimensional data, right? I say I'm writing a text data, number data, date, right? So these are the text, these are the structured data. Generally this type of data are there in the SQL databases. SQL databases we use structured data. That's the reason SQL databases are structured. Okay, and when I say unstructured is there is no fixed dimension, there is no fixed um, like a dimension is not there, right? So I can say audio, okay, video. So you cannot measure directly, you can measure the data, but you need some processing API, right? Audio, video, images, right? So there is a separate APIs are there, audio processing APIs, okay, in the Python or Java, any language, okay, video processing API. So you heard about these are the different APIs are there. Okay. Okay. So if I say unstructured data is the data which we cannot measure as without any tool, right? So that is unstructured data. There is no fixed dimension. So audio, video, images, these are the unstructured. And when I say semi-structured having the characteristics of both structured and unstructured. So I say some example is email. So email is having a subject is a text, right? That is a structure. Okay, and attachment is image. Attachment is a image, that is unstructured, right? And some other example are like CSV file, JSON file, okay, XML file. Any file system data is semi-structured data. So CSV file itself is unstructured, right? Okay, but I say the data inside the CSV file is, or we can say like in the XML, like we have a different tags are there. So there is no uniform, like if I say one employee tag is there, an employee tag has some properties are there. Okay, ID is there, name is there. So it is not necessary every employee tag has the same property, right? So we have a starting and end with the employee, but the properties could be different, right? XML or file itself is a unstructured. So CSV, JSON, XML, these are all called semi-structured data. So most of the time, like we are dealing with the in the big data tools, right? Like semi-structured data, right? We are processing the data which is coming through the file, and these files are sent by the vendors, right? Some vendors are sending their files and they want to process their data and write the data to the persistent data storage, like some SQL, NoSQL DBs. They want to store their data, permanent data they want to store after the processing the data. Or even we can, after the processing data, we can write into the file again, right? Suppose I read that file as a CSV. Okay, read CSV file, and after processing, transform the file. After transformations, again I writing a CSV file with the less column, CSV file with less columns, right? Okay, so this is our for the reporting tools. We will use it to generate the reports. Some BI tools we will be using. So here BI tools will come in picture. So Tableau, Power BI, these tools will come in picture. Okay, so I'm saying, so this is all called ETS. So we will be working on the data, mostly the semi-structured data, but structured data like in the SQL DBs we will be using. And if I say machine learning and data science related, so Python we will be using for the unstructured data, where we will be using different Python libraries for analysis of the unstructured data. So one example is for, right, suppose you have a different images are there, but you want to find a duplicate images. So duplicate images means you have to check pixel by pixel each images, right? And then find which are the duplicate images, and you want to delete the duplicate images. Okay, even MapReduce, we can write the program for that, but we have to use the binary format, because MapReduce program is a good fit for the MapReduce can be used for the any type of data like structured, semi-structured, semi-structured, and unstructured. Okay, if I say that, okay, hive is worked only for structured and semi-structured. Okay, semi-structured, but hive we cannot use the because the hive tables are not supporting to the right the images, audio, video, right? So we are using semi-structured, but Spark we can use all types of data, but we have to use for unstructured data, we have to use some image processing, audio processing APIs. Okay, because normal Java APIs will not be supporting the unstructured data, right? I told separately we have to use Python or Java library that can support the unstructured data. Okay, but all three are supported in the MapReduce in this. But MapReduce, you have to write 200 lines of code for a small program, and the same program you can write in the 5-6 line of code. So that is a huge difference in the productivity when you are using Spark over the MapReduce, because MapReduce is tightly coupled with the Hadoop. Okay, but Spark is you can use without Hadoop also, right? Suppose you have a less data, you have a not very big amount of data, you can go for Spark as well. Okay, so there is no tight coupling with the Hadoop file system. So structured, semi-structured, and unstructured data you can use. So these are the characteristics of the data. What are the different types of data? Okay, and now the next thing comes, what are the types of scaling is there in the, okay, so there are the two types of scaling is there, vertical scaling and horizontal scaling. Okay, so vertical scaling is supported in the SQL databases. SQL databases are the vertical scaling. Like in a same database machine, you can increase RAM, disk. Okay, but you cannot share the database across the machines, right? You can't install in machine different machine and share the data. So that horizontal scaling is not there in the SQL databases. Okay, but in horizontal scaling is we can make a cluster. We can make a cluster, and which has the node, which has nodes like number of machines, and we can add or remove the machines, add or remove nodes from the cluster, from cluster. And the size of the cluster will depend on the machine, number of machines, RAM and disk, number of machines, disk and RAM. So it will be shared, right? It's a like distributing, sharing concept, right? So horizontal scaling is supported in the NoSQL databases. Okay, all NoSQL databases, Cassandra, Mongo, they are like they are having horizontal scaling, right? So you can sharding is a concept to share the data across the machine in Mongo, and Cassandra also is the peer-to-peer architecture. So Cassandra is peer-to-peer architecture. Peer-to-peer architecture is every node is having the information about the other adjacent node. So that is called peer-to-peer. But MongoDB is master slave. Same Hadoop is a master slave. So master slave is one is a master and other nodes are the slave. So master is keeping the information about all slave, right? So any point of time is any slave node is down, so master will assign the another slave. The same architecture in the Hadoop also there. So horizontal scaling in the NoSQL databases and Hadoop file system. So Hadoop file system is also horizontal scaling. So you can add the number of machines or remove the machines depending on your requirement, right? Request of the data which is coming to your cluster, right? So you can add or remove machines, and that is called the horizontal scaling. So horizontal scaling is making your data processing faster. How? If I say 2 TB machine you have here, and you have max suppose 128 GB RAM. Okay, so you can process till 2 TB data, right? Till 2 TB data. So because you cannot process, like your disk capacity is only 2 TB. But if you have 10 nodes are there, 10 nodes, and each node is, I'm saying 2 TB and 128 GB RAM. So it will be total capacity will be 20 TB. Okay, and RAM is a multiply 128 multiply 10. So that will be configuration of the cluster. So that will be utilized, right? Like as much as RAM and the disk will be utilized to process the data, and it will be parallel processing. So first thing is like our, who will be taking care of this, right? How the communication will happen between the node. So Hadoop is the Hadoop. So every machine will be installed Hadoop first of all, Hadoop installation on each machine. Because if Hadoop is not installed on each machine, how the communication will happen? And the second thing is we will make it one machine, a name node, that is a master machine, master name node. We call it name node. Okay, and that is containing only metadata, containing metadata. Okay, so this metadata is nothing but data about data nodes. So what type of data about the data nodes? Like what is a IP of that data node, IP of data node, and how many blocks are there. So blocks concept I will tell what is how many blocks. Okay, occupied, and how many blocks are free. How many blocks are free. So we say the memory is or disk is in terms of like we say MBs, GBs, like that we calculate. Okay, but internally the any file system, not only Hadoop file system, so block concept is there. So if I say one block size, if I say in the Windows and Unix, right? Windows and Unix, this block size is only 6 KB. It is very, very small. Okay, but if I say the same block here in the Hadoop file system, so Hadoop file system, this block size, when Hadoop 1.x version was there, they kept a default block size 64 MB in Hadoop 1.x. But later Hadoop 2.x and 3.x, okay, they change it to default block size is 128 MB. And the reason is 128 MB, they change it because it's a configurable. You can change it, you can increase more or decrease, you can do. But the advantage is the larger block size is like if the file is large, right? Suppose I'm reading 100 GB file. Okay. So 100 GB file is like if 1 GB is these many blocks, so the number of blocks will be less. And when the number of blocks are less, so the reading the data from the file, reading data from files. So this could be 100 GB is a one single file, or it could be a number of files. Okay. So if I say the number of blocks will less and reading data from the files will be faster and processing will be faster. Okay. But if I say the same thing, if you try in the Windows, it will not be possible. Even some MBs of file, if you try to open Notepad, right, you will see your Notepad will hang because that Notepad, because this is because of the block size. So the design of the Hadoop file system in such a way, right, we are going to process very, very large amount of files, right? It could be a GBs, TBs, petabyte, exabyte. So as it should support first your disk capacity, right? Your cluster should have that much capacity. So as much as capacity of your cluster is there, you can process that much of size of the file. Okay. So internally the the size is divided into the blocks, and this blocks is larger. The block size is making the data processing will be faster. Okay, I will show in the MapReduce, right, how we will be processing the data. So how the block size will be having a significant role. Okay, so when we talk about scaling, okay, now we come to what okay, so in the fundamentals things is like, okay, one more thing is where we are using this Hadoop, big data, right, Spark, right? So all the industries, right, if we talk about any of the industry, right, so every industries have the analytics. So we are doing what exactly we are doing in the big data, right? So we say we are doing data analytics, right? So data analytics is, so if we have a question, right, we can do this data analytics in the any programming language also, like Java, Python, right? Java, Python, and other PHP. There are so many different languages are there. They can do, but thing is distributed computing and this Hadoop infrastructure will not be there, right? Storage plus computation together both are not present, right? So Java will be providing only computation part, right? So if I say I want to find I want to find some files in my local file system. I want to file which is having some greater than size, right? I say, so I want to search the file, search files in each and every directory, in each and every directory in my file system in Windows. I want to do that. I can do very efficiently with Java. I can use a multi-threading program I can write. So multi-threading in Java, I can write a program and I can do that. Okay, I can do. But when I say like I want to do in a multiple machines, right? So here I have to write some like Java web application, or I have to use like that application, right? There that can be get the data from the different machine, but it will not be that much efficient like Hadoop big data can do, because when I'm going to the Hadoop is providing computation and storage both together. So computation is there, okay, and plus storage is there. So when you want to compute your data, you can store the data after computation in the Hadoop, right? You can do Hadoop file system. So Hadoop file system will be used for the storage, and computation will be used here, like MapReduce is there, Spark is there, Hive is there. There are many other analytics tool are there. MapReduce, Hive is there, and earlier the Pig is there, but nowadays nobody using Pig. So Hive, Pig, and Spark. Okay. So if I say the computation part and storage part together in a one single unit, right? So whenever you process data, you can store data in Hadoop file system. Again, you want to process, you can read the data from your Hadoop file system. So the mandatory condition for the Hadoop is like the data should be on the Hadoop file system, but Spark is can be used like in any environment without Hadoop environment, or in Hadoop environment without Hadoop and in Hadoop. So without Hadoop means it is a standalone without Hadoop. So there is a standalone mode is there. So standalone mode is like where you have a file in your local file system and you can process the data in Spark. So Spark is having the advantage of the processing capability is more processing is faster than the MapReduce and Hive. Okay, because MapReduce and Hive both are Hadoop based. Okay, MapReduce based. So underlying in the MapReduce is using MapReduce itself, and Hive is using also MapReduce. So why still we need to learn the MapReduce? Because the Hive, Scoop, HBase, all these component, whatever component I talked about Hadoop, we need to learn the Hadoop MapReduce. So MapReduce is important here to understand the concept, like how MapReduce works, like what is a map function, what is a reduce function. So that concept is important to learn for understanding how internally Scoop, Hive, HBase, all these are using the MapReduce. Okay, so the main purpose of the MapReduce is to learn the framework, right? What MapReduce, how MapReduce works for the other tool like Hive, Scoop, HBase. Okay, and Spark is faster because Spark is faster than the MapReduce Hive. Okay, and because it is in memory computation. In memory computation means it's processing the data in memory itself. Okay, so in MapReduce also processing the data in memory computation. So what is the difference, like here, like MapReduce is not faster and Spark is faster? The reason is when MapReduce is processing data in memory, but intermediate output data, the intermediate output data, right? Suppose some processing is done, after that some output data is generated. That intermediate output data is stored in disk. Okay, so there is no provision, right? It can keep it hold data in memory, right, after the processing. So that is the already design is there. Okay, that design cannot change. Okay, so that is the reason MapReduce we say it is good for batch processing data. So whenever I'm doing some historical data processing, right, historical data processing, right, historical data processing, like weather forecasting data, right, 50 years data I have, and I want to process the data. So that kind of data, the MapReduce is good, right? Because it is not the real-time data. Okay. So batch processing data, because it is storing intermediate, so processing is taking time. That's not to worry. Okay. So if, because historical data, batch processing data, if it is time taking, that not an issue. So it is not a problem if batch processing taking time. Okay, because it is already the huge amount of data, and the like it is not storing the data in the email like memory, right, after the processing. So that is the reason it is again reading data from the disk. So it is reading data from disk for further processing. Okay, so if somebody asks you, right, why like MapReduce is not faster than Spark is faster, because Spark is intermediate output data is stored itself in the memory. So that is the reason when you are using Spark, the memory configuration should be very high. So memory configuration is a very big constraint for the Spark memory storage, right? Memory means like a RAM. Okay, so memory configuration should be high. Configuration should be high, because if it is high, it will be giving you the better result. If it is not high, it will be giving you the result, but it will be giving you the result as the same as the batch browsing. Even you are using Spark, but you will not get the benefit of the Spark. So if you want to get the benefit of Spark, so Spark memory configuration RAM should be high. Okay, so but if you want to use the Spark for the as a batch processing, you can use. So Spark has both options. So Spark can be used for batch as well as real time. So why real time is important, like Spark job should be faster, because here we cannot wait for that, right? If I say credit card swiping data, okay, so when I'm doing credit card, like some analytics I want to do, I cannot wait for that, right? So the real time data is coming. So when the real time data is coming, okay, it is coming like through. So like we can take an example of like live streamings are there, like so live streamings are there, and we want to do analytics on the live streaming. So cricket match is going on, and we have to do the analytics. The cricket match is going on, what's the status of the teams and everything, right? So that is done at the real time. Okay, so that is the Spark is the best solution for that. Okay, so we can say these are the analytics tool. Okay, so when we start the Hadoop, right, so first we have to, Hadoop is not a single tool. Hadoop is a lot of components are there. So what are those components are there in the Hadoop? So Hadoop components are called ecosystem. So these ecosystem component, is we start from the SDFS. Next we go to MapReduce. These are the two core component of Hadoop. If you have installed Hadoop, you've seen there the total 5 services are there. So 3 services are the SDFS, name node, data node, and secondary name node. Okay. But when we are using a Hadoop 2.x and 3.x, so there is yarn architecture is there. So there is a standby name node is there. So that I will tell. So these are the typical like you have seen the resource manager and node manager, resource manager, resource manager, and node manager. The total 5 services comes. Okay. So resource manager is having the high availability concept, right? It is not only processing the data, it is maintaining the high availability by using the standby name node. So resource manager is a master of the node manager. Okay. So here is the terminology is very simple. Like when I say name node, this is a storage. These are the 3 storage components. So these are the storage. Okay. And this is the processing, node manager and name node, resource manager, the processing component. Okay. So when I say name node is containing the metadata, which is data about the data node. Okay. And data node is containing actual data, Okay. So we can say, right, when we are storing the data in the blocks, right? So all these blocks are on the data nodes. Okay. So the blocks of copy on these different data nodes. Okay. So there is a replication factor that I will tell about in the Hadoop, right, when I start the SDFS. And the next is a secondary name node. Secondary name node is a node which is a backup of name node. So we are saying Hadoop is providing the high availability. So this concept we say, like this is implemented by the secondary name node. When name node is goes down, because this name node is a single point of failure. It is single point of failure. What is the meaning? Single point of failure means if this name node is down, entire cluster will down. You cannot communicate with the cluster. When you send a request to the name node, I want to read this file. So name node is down means entire cluster is down. In that case, like there is a backup is their secondary name node. So secondary name node is always syncing the metadata, because secondary name node is not containing the actual data. It is also containing the metadata same as a name node, backup node, and it is containing same metadata. Okay. And this metadata files are there. I will tell you. There is a one is a FS image file and one is a edit log file. So one is a memory copy and one is a disk copy. So FS image file is a memory copy. Okay. So whenever your name node down, right? So this memory copy will gone, right? But edit log file will be always syncing with your memory copy, because this memory copy FS image is always loaded from the edit log only. So your disk copy is always updated. Okay. So I will say like whenever your system, this name node machine goes down, right? So your edit log copy will be there in the disk. Again, your system will reboot. Then your FSMS copy will be created from the edit log. So secondary name node is also maintaining this FSMS edit log so that they both are syncing. So secondary name node and name node both are syncing. But there was a one problem. This architecture is used in the Hadoop 1.x because there was no secondary standby name node concept was not there. Okay, resource manager or node manager. So in Hadoop 1.x, name node, data node, secondary name node was there, but the MapReduce side, it was job tracker and task tracker. So earlier name was job tracker and task tracker. So job tracker is assigning the task to the task tracker, and task tracker is doing actual task on the data node. So job tracker is a master of the task tracker. Same like name node is a master of data node. Same thing. But here is like job tracker is assigning the task to the task tracker. So same thing, resource manager is now doing the assigning the task to the node manager in the Hadoop 2.x and 3.x. Okay. So earlier job tracker was not doing the management of the resources, because it is just assigning the task and getting the result of the task and giving to the name node. So who is communicating? First is a name node. Name node is getting the request because it's a single point of contact, right, to the entire Hadoop data cluster. So when any client means any user who is requesting to read a file or write a file in Hadoop file system, so it is contacting to the name node, and name node is connecting to the, if it is a 1.x, it will be asking to the job tracker, or if it is a 2.x and 3.x. So nowadays 1.x nobody using, we are using 3.x. Okay. So resource manager, it is asking to the resource manager and resource manager like find the available. Okay, what name node will give? Name node will find first what name node will do, it will find available data nodes. It will find available data nodes, data node where data can be processed. Data can be processed. And these data node IPs, these data nodes IPs given to resource manager. Okay. And resource manager assigning the task, resource manager assigning the task, assigning task to node manager. Okay. On the same data node machine. On the same data node machine. So every data node machine, one node manager is there. So when the resource manager will get the IPs of the data node in the same data node machine, the resource manager will assign the task to the node manager on the same data node machine. Okay. And data node machine will be completing the task and given back to the resource manager. So here is communication is name node can do communicate with the data node. Okay, because it's a master slave architecture. Okay, between the name node and data node. Name node can communicate to resource manager because both are the master, right? So who is doing the task? Who is assigning the task? Resource manager. So name node has to contact to resource manager. So this communication is there, and resource manager has communication to node manager. But there is no communication between the name node and node manager. Okay. So both are communicating with its master. So any point of time, if we are saying, okay, how name node will find in any data node is alive or not. So there is a heartbeat mechanism is there, heartbeat mechanism. So heartbeat mechanism is like every 10 seconds, like name node will be sending a signal to the data node, all the data nodes, because name node has the information about all the data node in the cluster. Okay. So every data node, okay, name node will send signal. Okay, it's like a just a like a ping, current kind of ping, right? Because if it is not replying back means it is assume it like it's a dead, it is not it is crash or anything could happen. Okay, so name node will send signal to all data nodes, and if it doesn't get back acknowledgement, acknowledgement or signal back, okay, signal back to name node, then name node will assign another data node to resource manager, right? So resource manager, it will tell. Okay, same point of time, resource manager is also sending signal, will send signal to the resource node manager. Okay, node manager. So sometime like your data node is fine, but your node manager is not doing task because some memory issue is there, right? So your your task can be failed, right? So it is not a problem in the data node. Data node machine can be down. In that case, your task manager, node manager cannot do work, right? But there could be a situation, resource manager will send a signal to the node manager, but node manager is failed. Node manager is failed somehow. Okay, and it is not responding. It is not responding. So what it will do, it will find, like it will, when the data node will assign the another data node, it will assign that same task to that data node. Okay, and there is a node manager. Okay, so this kind of communication happen between the in Hadoop architecture, and this is all internal. So we are not worried about how, suppose I say I have a one file, and I have to store this file in Hadoop file system. Okay, so when I'm storing this file in Hadoop file system, so how the file is distributed, this will be decided by the namenet. How files will be distributed across the nodes will be decided by the name node. Okay, and when you are retrieving the file, same file, when you retrieve it, when you say name node to get the same file, Okay. So name node will identify what are the name data nodes are there where the data is stored. Okay. So this is called the read and write anatomy. Read and write anatomy, like how the read and write happening, read and write anatomy, how read and write is happening in the SDFS. Okay. So one more concept is there, rack awareness. I will talk about that. There is a rack awareness, how the data is stored in the racks. So if I say rack awareness, so we have the data center and data centers having the racks and racks having nodes, right? So if I say, suppose this is the first rack and it has like one machine, second machine, third machine, fourth machine, and fifth machine. Okay. And another one rack is a second rack. This is the second rack. Okay. So what will be the policy, right? The how that, so there is a replication factor will be there. If I have a one copy in this first rack, first machine, the second rack, I will have the replicas will be there. Because in the same machine, if I keep it replica, there will be no use, right? Because if suppose this connection is goes down, right? If this connection goes down, I cannot access any of the node, right? So I will have the access of different rack, so that if one rack is not accessible, so second rack I can access my other two copies. So default replication factor, if I say here is also one machine, second machine, third, so I will keep it one copy here and adjust two copies in this node. Like this, I will define my rack awareness. Okay. So this is the policy, right? How Hadoop is doing. Hadoop is storing the data as a replicated data, right? So how to provide the high availability. Okay. Anyone has any questions so far? So this is fundamentals. I will deep dive into Hadoop tomorrow architecture. Okay, first I will cover SDFS architecture. Okay, and I will start the already you guys installed the Hadoop, right? And then we can do the Hadoop command, SDFS command. Okay, so this all architecture, these all things I will send the book, right? When you go through it, you will easily understand like whatever I taught, right? So how it is like meaningful here, right? So you have to do some studies, right? Because I am not saying listening is the one way, but you cannot capture all the things in mind. But when you do study, right, when you go through some theoretical learning, right, so you will get the conceptual idea, right? What are the concepts are there, right? Securities concept are there, encryption, decryption, right? So what type of securities are there? These are the little different concept, not related to big data, general concept, right? Okay. But as much as you but later on, like now Hadoop things will start, because initially they have given a general concept, but when you start from the second chapter, this will be completely Hadoop architecture things, right? So you will find I will share another book, because this is little bit like general concept one. Okay, it is not coming as a purely Hadoop infrastructure. Or maybe here, like see high availability things, Hadoop 1.x, 2.x. Okay, so this I will cover all I will cover like SDFS, name node, data node, so rack awareness, right? So whatever I'm telling, data replication, data node, name node is a safe mode, right? So secondary name node. Okay, so this theoretical things, you at least you know, right? What is SDFS? What is SDFS component? What is map reduce? What are the component and map reduce? What it does, right? At least four lines you understand. Like if anybody asks you what is architecture of the Hadoop, so you can explain SDFS and map reduce both. If somebody asks you SDFS only, so you can explain Hadoop file system, right? There is a name node, data node, replication. What is the concept of replication? What is the high availability concept is there? Heartbeat mechanism is there. So this same thing, whatever I explained, the same will come in the architecture, right? When somebody asks yarn architecture, so you will speak about the resource manager, node manager, right? Okay, so what is the difference between the Hadoop 1.x and 2.x, right? Okay, so those things. So here is every tool wise tool is going, so we don't need to go in hurry, right? Because there is a scoop tool is there. Okay, we'll learn everything, but I'm saying first fundamental is very important, especially this Hadoop architecture. So if you understand Hadoop architecture, then any of the tool is just very small tools, right? Like it's nothing to do more on that tool, right? Just do practice on the command so you can learn. Okay. Okay, anyone has any questions so far?
No, Arvind.
Okay, I will share the recording in the classroom. I will create in the same classroom link. We have a one installation video is there. I will create a one title and there I will add this video, and I will add the PDF and document also. So you can study there. Okay. Okay. Thanks everyone. Yeah, we'll connect.
Thank you, sir.
Thank you. Bye.
Thank you.
Thank you.